Some of the core production processes for AT&S printed circuit boards take place in clean rooms. This film presents two different technologies for placement of components on printed circuit boards and the back-end process. The smallest particles in the air can impair the quality of the printed circuit boards. Therefore, clean rooms offer controlled air supply and exhaust, as well as humidity and temperature control, which minimizes the number of particles. Windows are tinted to filter out harmful UV light. All employees wear special cleanroom clothing to prevent the introduction of particles and electrostatic discharges onto the components. Two processes take place in the placement cleanroom. They are used to assemble printed circuit boards with components ECP and CCE. In this process, parts known as components with a size of 0.5 to 50 millimeters and a thickness of 50 micrometers to 4 millimeters are placed directly into the printed circuit board. This helps to keep the circuit boards as small as possible while increasing their functionality. The first method presented is ECP, or Embedded Component Packaging. At the beginning, the copper foils are cleaned. While still outside the clean room, they are moved into pre-cleaning. Compressed air is used to remove all dust particles from the top and bottom of the copper foil, which can then be introduced into the clean room. In the next step, adhesive pads are applied. These provide a firm hold for the components placed later. In the adhesive printing machine, the screen is placed over the copper foils and adhesive is applied to it. Using a squeegee, the adhesive is evenly distributed through the mesh of the screen into the copper foil. To prevent microscopic air bubbles from impairing the adhesion and functionality of the components, these bubbles are extracted in the following step by means of negative pressure generated by a vacuum. Now the copper foil is ready for equipment. The placement machine is the heart of the clean room. Its task is to pick up the components from the so-called feeder and place them on the adhesive pads of the copper foil. Using negative pressure, the placement head sucks in up to 20 components simultaneously and places them in just a few seconds. Despite the high speed, its accuracy is up to 15 micrometers. Finally, the copper foil with the mounted components is placed in the oven, where it is heated under pressure for 45 minutes. The adhesive hardens in the process, and the components are thus permanently fixed to the copper foil. The ECP process is now finished, and the assembled copper foil is delivered to the next department for further processing. The center core embedding process, called CCE, differs from ECP in that the components are inserted directly into the core. A core consists of two copper-clad fiberglass mats separated by epoxy resin. A laser cuts the openings for the components out of the core. The core is then delivered to the clean room. From the pre-cleaning machine, the core moves directly into the laminating machine, where an adhesive film, known as sticky tape, is attached to its underside. In the placement machine, the components are inserted into the core, similar to ECP, and fixed in place by the sticky tape. The equipped core is then put under the microscope. The AOI machine inspects the components for cracks, fractures, and misplacements. If defects are found, they still have to be verified. The employees must then decide whether it is a pseudo or an actual defect. When the verification process has been completed, the equipped core is sent to the next clean room, the SLS press. The core is now pressed with a prepreg and a copper foil. In the heating press, the resin of the prepreg melts and flows into the openings. In the cooling press, it hardens again and thus fixes the components permanently. In the last work step, the applied adhesive film is removed again. The core is now fully equipped and pressed, ready to be passed on to the next department. When several individual cards are combined in the production of printed circuit boards, this is referred to as a panel. In the back-end process, these individual cards are cut from the panel and prepared according to customer requirements. The first step is tape mounting. For this, the panel is laminated onto a tape inside a metal frame. This is followed by the cutting process, known as dicing. a rotating blade cuts the panel into individual cards. The process is cooled with water, and this way the milling dust is captured. The individual cards are then cleaned with water and dried with compressed air. Through exposure to UV light, the adhesion of the tapes is reduced, making it easier to remove the individual cards from the tape in the next step. In the test handler, the individual cards are removed from the tape by pickup heads and then passed on. A laser marks each individual card with defined order data. Subsequently, all cards are tested for electrical functionality and visually inspected. All error-free cards are now placed in a belt with pockets, sealed, and wound onto reels. The finished reels are placed in the drying cabinet for 3 days at 60 degrees Celsius, where the last moisture is extracted. Finally, they are vacuum packed in moisture barrier bags and are ready for shipment to customers. Assembly, SLS press, and backend. 3 processes in clean rooms at AT&S that demonstrate the miniaturization, high sensitivity, and high quality standards of our industry.